In this workflow, we will cover the Inversion Tracker, called as well Unconformity Tracker. Traditionally, the trackers follow amplitude and phase, whereas unconformities do not show consistent amplitude and phase behavior, consequently cannot be tracked with a conventional tracker. This Unconformity Tracker method flattens the deep field using a constrained inversion-based algorithm. The constraints are given in the form of picked position and optionally a confidence weight volume. In this exercise, we will create two horizons, one seismic event constrained by a few manually picked positions and an unconformable event constrained by well markers. First, we will prepare and display the necessary data for this exercise. Preload the default seismic to the memory, survey, preload seismic data, load cube, and 4 deep stirred median filter, OK, and close. Add default inline to the scene, right-click on inline, add default data. Add a random line crossing the 4 wells, right-click on random line and select random line through wells, OK. Add the 4 wells to the scene, right-click on wells, add. We select all the 4 wells and OK. Then right-click on 3D horizon, new, and track using inversion. In the Inversion Tracker window, we select as steering data the steering background detail. Ideally, this detailed steering cube should have been calculated on an enhanced seismic. Optionally, we can limit the output extent from the volume subselection. It's possible to change the point set name and the horizon name just by double-clicking on the field. So we click on the pick seed icon, move the window to the side, and we pick few points on the event we want to track. Minimum 3 points. With a complex seismic, normally we need to pick more points, especially in the area where we think that the tracking might have some difficulties. So we can switch off the picking mode. Alternatively, we can open an existing pick set with interpreted points from the folder and select the corresponding interpreted points. We can just cancel for the time being. For the second horizon, select FS7 marker from all well icon with the well and selecting FS7 marker all wells and OK. Select the processing parameters. You can optimize all these parameters and have more information by reading through the info icon. For example, a good confidence weight is the planarity volume that we can select or create. We close this window and run. The batch processing finished, so we can close the progress viewer and the Inversion Tracker window. Then add the new tracked horizons to the scene. So we go to 3D horizon, add, select surface constrained by strain 1. We kept the default name, and surface constrained by FS7 and OK. For a better QC, we can constrain to the section, so we right click on the surface, display only at section. Similarly for the other horizon. We can change as well the color bar of the seismic to grayscale. Similarly for the random line. We can set the step for the inline to 10, for example, and change position and scroll through the cube to QC the track horizons. We zoom in, we can see that it's following nicely the events. We can QC on the random line as well for the second horizon we tracked at the marker level, and similarly we see that it's tracking the events very nicely. If needed, we can improve the tracking by adding more peaks in the complex seismic area and eventually adding a confidence weight volume, the planarity for example, or changing the inversion parameters. This concludes this workflow where we show how we track seismic events constrained by few manually picked positions and an unconformable event constrained by well markers using the Inversion Tracker.